Tonight we're going to talk about how to make 4 of 24 using SolidWorks 2018. We start the usual way. We start a new file, part file. All of this I'm going to speed through because you know how to do this. We're going to turn on our planes, make them visible, and now the question is, where do these views belong? We have a center cylinder and we have two outer cylinders. This one is actually flush with the bottom, and this cylinder here is flush with the top. Okay, I would start with the center cylinder if it was me. That's how I would begin my part. I would just draw the cylinder, drop in the smart dimension at diameter of 2, and that's it. This is what I would turn around and extrude at a height of 2.5. That would be the center piece. Now, off the top, I would create a new sketch that will, if I go to normal to, go to that face to work on, this will be over here, the smaller diameter, this guy. I will actually throw in a center line so I can drop in my dimension and make sure it stays horizontal at the same time. That one's 3 inches. And then this dimension here, the outer diameter is 1.06, which we know is actually 1.0625. And our reference fraction decimal chart helps us with that. The 0.0625 is in this family over here, 1/16 of an inch. So this, when you see 1.06, please never assume that 0.06 is 0.06, literally. That's dimension to the tolerance, not dimension to its real value. So keep that in mind. Some of these will be challenging when we think of that. So 0.0625 is the number we use. It shows up as 1.06 here because we're showing everything to 2 decimal places. Remember that. This then turns around and becomes, goes and gets extruded. I am going to go to the isometric. I don't like that cube, to be honest. Go to the isometric view so I could see which way it's extruding. We actually want to flip it so it extrudes down. The distance is 1.375, 1 3/8 based on this information. We hit OK. There's that one. To build the bottom one, we actually tilt this up a bit so we can pick the bottom of the object. Now notice I'm picking the bottom of the object and I'm not picking the plane. I don't ever want to pick the plane after my initial object. I always want to pick an object to reference from versus a plane. A plane can result in a disjointed feature, meaning that the feature could be here but not really associated with the other elements of the model. I want all the model elements to be associated to each other. So that's why I'm intentional in picking that face specifically for where I want to build my sketch. Now when I build this guy, this is the weird one because it's very hard to look at this. You have to go into the top view. You have to go into the top view to get this right. If you go normal to, you're actually going to get the underside of the part because remember what I selected to build from, the underside, because I wanted to pick the bottom of that part because that's what I wanted associated with. But for viewing purposes, to get this right, you have to look at it from the top. When I build the diameter here, that's 1.5. Now you have a line, a connecting line from this center to this center. This is where things get tricky as well. Visually, this drawing is a little challenging. That's a conversation we had before we started the video, because this really looks like it's 90 degrees to this, and I agree with you. But that is really the deciding factor right there, the 45 degrees. That's really what dictates what we do. Yes, should we talk to the customer and say, hey, we noticed politely, dear customer, did you want this at 45 degrees or at 90? The one dimension shows 45, but visually looks like almost something else. So you can ask that question, it's okay. Personally, this is just bad positioning by whoever put these on there as reference. My guess is maybe they forgot about those dimensions and had to throw them in later and just, dump them wherever they could. So anticipate that happening. So this is at 45 degrees. The distance from this object to this object is actually, and the hypotenuse is 2.875. Keep that in mind. It's not 2.88. Remember, 2.88 is 2.875. Please remember these facts. You must remember these facts. Yes?
If you want to go, it's 2.88, but isn't the 0.88 28125 closer?
8125, no, because the 12 will round to 13. And then that'll round to 2.812. Yeah, it'll round down, won't round up. In order for something to round to 0.88, I need it to be like 0.87 and then, or 0.881, 0.875 or higher. So there's a range, you're right. There is a range of numbers. If I go in here, let's see what the range is. Yeah, it could be 113 over 128. I agree with that. That's 0.88. Because 0.8828, yeah, technically these two would round to the same two decimal places of 0.88. It would round to the same two decimal places. You're correct. So I could pick either one. I'm going to be a little sloppy. I'm going to say 7/8 of an inch. I'm not going to go hardcore precise and 132nd, 113 over 128. I'm not going to go that way. Sorry. I'm going the other way. I'm going to 7/8. I will hit okay, but you're correct. I agree with you. You're absolutely right. So we're going to hit all right on that, and then we're going to go ahead. Again, I'd like to go to isometric so I can see what I'm going to do. There's your 0.875, 0.88, rounded. And extrude. That wants to extrude down because I picked the underside of the part to build from, so now I got to flip it again to extrude up. And that height is also 1 3/8, so we're good to go. So that geometry you could do on your own. The ribs, I'm going to say that you want to offset the planes. We talked about planes before when we had that more complex part with planes, so I'm just going to go ahead and pick that face and automatically jump to what I need to do because you've done this before. I'm going to say this is parallel to this guy. Parallel to that surface though. Parallel to, okay, I hit something wrong. 1 second, let me try this one more time. Plane, I pick my face, and you can't drag it. That's what I did, I tried to drag it down. That's in a different software package. 0.5 is the distance, okay, but I'm going to flip the direction so it goes down, 0.5. Then I'm going to hit OK. Notice I picked the face to do that with. And this is the plane I'm going to build on. I'm going to go normal to so I can look at it head on. Now in my infinite lazy way, I'm going to draw 2 lines out here in La La Land. I know they're tangent. Why? Because this is a beautiful smooth transition here. And this is a beautiful smooth transition here. That's the only reason I'm presuming that it is tangent. Okay? Now I'm going to turn around. I'm going to use my keyboard control, pick my line, pick my object, and then I pick tangent. Because I take the KISS approach to getting this done. Pick my line, hold my control key down, pick my circle, tangent. Hit OK. Pick the circle, pick the line. Notice it doesn't matter which order. Tangent. Keep it simple. Pick my line, pick the circle, tangent. Then I would trim, so I could trim off the ends. But then I realized I can't trim. Why can I not trim? Let's find out. I should pick trim the closest. That's the better choice. But you see, look at that. No, it doesn't. It trims off everything. So what am I doing wrong, guys? Even though I was able to make a tangent to the side walls of that object, is there really a circle there for me to attach to? Is there a perimeter there, a real one that I can actually connect to? The answer is no. It's tangent to the side wall of an object, but it doesn't have an intersection point. If it doesn't have an intersection point, it can't be trimmed to something. Okay, that's where the problem is. I'm trying to do visuals while I'm saying this. For those of you online, you're not seeing the visuals. But if I move this back and forth, you'll see that there's no handle for it to really attach to. Only when I do convert entities and I pick my circles and I hit OK, boop, then I've got something to attach to. Now I can trim. It's not because I've changed the orientation. I did that so you could see what's happening. But now I can trim to that object. Before I could not. Just be aware of that reality. Now I'm also ready to go ahead and extrude. And this object is going to extrude down, not up, because remember I put it 0.5 down. It's this piece of it. And the thickness of that is 0.375 because that's 0.38 is rounded of 0.375. So there you go. The bottom, now I know that you see these lines here, and that's annoying. And that's only because of the representation display style that we picked. The default one, which is shaded with edges. And technically, the tangency point is quote-unquote an edge. It is the one point of contact. If I make it shaded without edges, then you see how beautiful that marriage is right there. See that? Isn't that gorgeous? It really is tangent. If I rotate it and the light hits it, you don't see an edge. You don't see a shadow in that spot because it's tangent. Okay? So that is true. That's showing it true. See that? That is correct. That's how it looks. That's how it really looks. But when we show edges on, you also see the tangent edge. Doesn't mean it's not tangent. It's just edges on. The next plane is from the bottom. You've done this one as well. From the bottom of the object, okay? Whoops, I actually have to pick reference geometry plane. Now it bounced down, so we're going to flip directions. We can go up half an inch because that's what it says. We're going to hit OK. This one's a little more challenging visually because it's not tangent. So when we get into the top plane of this one, you realize it's 1 3/8. So you can draw these lines, make sure they're not connecting to anything. You almost have to draw them out in space, back to my reference of drawing in La La Land. Not really drawing anywhere specific. You want to make sure these lines don't hook onto anything. You do need your center reference line for this, to do this right. Okay? Because your next line is going to be referencing a couple of things. This over here, if you see this, you've got this 1.13. That's the distance, the linear distance from here to here. 1.13, which is 1.125. So in order to do that, let me go to isometric real quick so you could see it. First thing I should do is what? Convert entities, right? Because I need these references down there. That's number one. Number two, I'm going to draw a line. I can draw a line connecting this to this. That's okay. But I got to drag this point so it's touching what? Touching that outer curve. I can't really see that clearly in isometric. The only place I could see that clearly is in the top view. So I got to drag this and have it touch the object. Drag this and have it touch the object. See that? That way I know they're connecting to that circle. These guys will get dragged back so that they're touching their object. See that? I could trim back for those. This, however, is what gets dimension. This gets a dimension, that hypotenuse, that angle dimension. That's 1.125. Now comes the fun part. I want this thing to level off. The easiest way to do that is perpendicular constraint. So I take these two and say I want you to be perpendicular, meaning 90 degrees to each other. So now, mathematically, you've locked it in. Literally, pure geometry.
1.25, what did you...
The 1.125, this guy? The 1.13?
Okay, 1.
Yeah, it's 1.125. Yeah, because it's 1.13 in the drawing. Yeah.
You needed the center line was so that you can get the...
So I can make it perpendicular. I gotta lock it in at 90 degrees. That'll make sure that line doesn't wiggle.
So if you're holding control key down,
That's what I always use. The other way, if you don't use your control key, I like to not be too keyboard or mouse dependent either way. The mouse method is you go up here and add a relation. Remember that. That's the mouse I'll call it the mouse method. So if I delete this and rinse and repeat this action using the mouse method, where I go up here, I go find the toolbar, which is under sketch, I add a relation, I pick this object, I pick this object, and then I pick perpendicular. And then I say, okay. That's the other way to do it. Me, and I'm a little old school, I guess, on this one, but I like to use my keyboard and my mouse. I like to mix it up. So that way I don't end up with carpal tunnel. If I hold I tend to hug the left side of my keyboard, so I'll use the escape key a lot and the control key. When I hold down control, I can pick these two items, 2 clicks, and then pick perpendicular, and I'm done. I don't have to remember where the command is in the toolbar set. I don't have to hunt it down. The act of picking those two objects, literally, just the act of holding the control key down, picking my center line, picking my solid line, just the act of doing that brings me into these set of options to add perpendicular constraint. That's why I use that method. That's the only reason. For me, it's a little faster, but that's because I'm comfortable going both ways with the keyboard versus the mouse. I work both at the same time, all right? So whichever one you're more comfortable with, that's up to you. The last thing I need to do is add the 8 degrees, because there's 8 degrees in there. Mathematically, we know that 8 degrees this way is the same as 8 degrees the other way, meaning I don't have to, stop that. I don't have to, will you stop that? I know, telling it to stop doesn't help, I know that, but I'll keep talking to it. All right, let's try this one more time. Go away, all right. There is no critical need to put in a reference line out here or a reference line out here, is what I'm trying to tell you. Some people insist that they must have these and that all 3 of these must be parallel to each other. That's up to you. And look, I got an error message. Yay. By the way, when you have ketchup and mustard, what does that mean? That's not a Chicago hot dog. You got it, man. But I don't like mustard. Oh, well. I do. In the world of CAD, Solidworks specifically, sadly it's got nothing to do with hot dogs. This guy, we locked it in somehow. I did, not we. So I want this and this to be parallel. Do it at one time. There we go. And then I'm going to, this guy I think I locked into something. Yeah, it did. That's why it doesn't want to behave. So now let's see if it'll behave. Pick this and this. Make it parallel. We're good. Some people insist on doing this. And then they want to put their dimension in. It doesn't matter. Because if you remember your geometry rules, whether I have 8 degrees on this side or 8 degrees on this side, see that? They mean the same thing. That's why you'll get this message. If you ever try to put a dimension in that literally is countering or another dimension, it'll say, hey, you can't add that dimension, but we can throw it in as a reference if you'd like. Okay? That's why we don't do that. It doesn't matter which way you want to do it. It's just one less step. You don't have to build these in to put the 8 degrees in. But what is nice about putting the 8 degrees in this way, remember what we talked about before, whatever you do in here directly correlates in your detail drawing. We had that discussion before. So if I put my 8 degrees in this way here, they're going to appear this way in my detail drawing. Did you hear that? Just remember that. If I show it in here this way, it'll appear that way in my detail drawing. If I show it the other way, meaning instead of dimensioning from out here, I dimension it from in here, which is the same, saying the same thing, 6 of one, half a dozen of another. If I put the 8 degrees in there, then in my detail drawing, it'll want to show the 8 degrees inside. Okay? So you do have to be intentional in how you want. If you want a detail drawing to appear a certain way, then you dimension it a certain way here. Because the two have a direct correlation to each other. The way I have it in here is exactly the way it will appear in the detail drawing, the default way. And remember, your dimensions, if you pull them from your model into your detail drawing, those dimensions will drive your model and vice versa. Okay, just like your model drives your detail drawing, if it uses model dimensions, will drive your model. So you have a lot of power, a lot of opportunity for modification on the fly, where you can literally tweak your model from your detail drawing, which otherwise you wouldn't be able to do if you manually detailed your drawing. And I recommend never manually detailing a SolidWorks, Inventor, Proe, etc. type drawing. You want to be able to be, you want to be pulling the dimensions in from the model. Because that's actually a really neat feature. One of you pointed that out last week. You were excited to see that, right? That is a wonderful feature to have, to be able to literally control your model from your detail drawing. Yeah, it's a wonderful tool, but you can break that tool really rather easily by ignoring how you detail things and then manually dropping in dimensions. So all of a sudden you shatter, you turn a Ferrari into a junky little car. So, anyways, that's the goal not to do. So now we're going to extrude the center piece. We want to go up. 3/8 of an inch is fine, so that's that. There, you've got that. Now the elements we've extruded. We've extruded all the elements. Now remember how we said after you have your model built, then you start whittling away at it, a whittle at a time. Is the way I say it. So now that I've built all the features, now I can subtract elements. We've done all the additions. Now we're going to work on subtractions. Got it? Over here at the front, we can use what? The whole wizard, right? Now remember, pick the face first, then the whole wizard, not the other way around. The other way around makes a lot of extra work for you. We're going to do a through hole. The inside diameter, that's 1/875. That's one of the things I do like. When you just select this and then you actually find the drill bit, 7/8 inch drill bit. Okay, I like this because it's real. Okay, then when I go to position, a lot of people will just draw anything, and then those of us on the manufacturing side of the house, we're in the shop side going, oh yeah, we're going to make that diameter hole. Yeah, where's the drill bit for it? We nibble it, right? You have to ream the hole out because we don't have the drill that's the right size. It's a lot of extra work, right? How many extra steps? On the machining side, we might add like 2 or 3 extra operations if they use a weird diameter, right? Pre-drill it, ream it, exactly. You got all these extra operations.
5 days, you want to have a hole like 6 10.
Right. Yeah. So all of a sudden you've got all these extra operations, which you could avoid if you just use a standard drill. Finishing it, you have to finish the inside anyways. That's another conversation. But there's your 7/8. Take this face. What's the size of this one going to be? The middle one? 1.06. Now that one you might not be able to find. I think this stops at 1. So you're going to have to use what they call legacy hole at a diameter of 1.0625. The depth is through all, that's okay. Then the position is centered. We hit okay, so there's that one. This guy, it's going to be another one. That's a diameter of 0.56, so it's 5/8. That one you will find in the drill bit options. Just the drill size. 5/8, right? 625, that's 5.56. Is that 5/8, guys? Crickets. Shouldn't be. Can't be 5/8.
9/16.
Yeah. See, 5/8 is 0.625. So, what was it? 9/16. Yeah, 9/16. Okay. So let's run down to 9/16. Okay, 9/16. It's through all. Then we go to position, centered, hit OK. Done. So there's your basic holes. Now you got to cut the keyways. This you can cut on your own, the slot in front. So I'm going to leave that to you guys. Here, though, the keyway conversation. Now we're getting to the key problem that some of you are having. How do I build that correctly, right? That's the biggest challenge. In here, I would first make sure I have my angle correct. So I throw in a reference for myself, a center line reference that I can go ahead and dimension. When I, whoops, not the center point. I need to dimension line to plane. This is set to 30 degrees, okay? Now you're going to find out the easiest way to do this is convert entities. How often do I use convert entities? All the time. The bigger question is, when do I not use it? The key is to turn this object into construction geometry for construction, okay? And then of all things, you're going to extend I gotta open this up over here. Extend this line out to the back edge. I want the back of this line, see that, attached to this. So notice how it moves now. Isn't that annoying? The reason it moves is before I had it to the center, and then I extended it past the center, so now it's lost. It's an annoying thing. If you pick the line and pick the center point, you could do something called coincident, and it'll lock it back into that center. Coincident is the relation I would use to make that happen. So now it is locked back in there. Coincident is the one you want to use. Now you have a reference for yourself of where you can put another line. This line you want it to be perpendicular to this line. And this reference line, if I offset it, this is one way to build it, not the only way. Okay, I'm just giving you a method. As with everything else, there's always more than one way. I'm just showing you one method. Now I'm going to go ahead and offset this entity up. I reverse its direction. A distance of 1 point, what was the number? 1/8 is not 1/8. We agreed on that earlier. It's not 1/8. We agreed that
1796875.
179, oh boy. What was it?
1796875.
17968. So it was 23/64.
128.
1 and 23 1/28. 1 and 23 over 128. Is that what we said? That makes it as precise 1.1796875. I did it that way just to show that you could. See that? When I hit OK, that's my reference right there. Now I can go ahead and offset, again, I can offset this line over 0.125 and rinse and repeat in the opposite direction. Then I have my basic geometry. I can go ahead and extend this line out. I can then trim it back. See that? And everything stays where it's supposed to stay, meaning that this dimension is 1.18. Okay, back here though, you start seeing some little snafus. You've got to trim back some of these entities because obviously it's a round back. And then you have the snafu of this spot right here, where this object is a construction line, and this is a solid line. And what do we know about that? What kind of element is this? What kind of sketch is this? Closed or open? Technically it's open, because this one's a construction. If I go to extrude, I should get a very strange shape, and I do. Because it's open geometry, it doesn't know what to do with it. It's very confused. So when you get that, stop yourself. You really do have to close it. Like these lines up here are extending way out of whack. Okay? These are too far out as well. They don't have to be that far out. See? Up here, however, what do I need to do? I need to convert this back into a circle. A normal circle that I could use. Because now when I do extrude, not as an object, take that back, I want to extrude it as a cut. Now I should be, bingo, I should be able to pick that. Because that's my keyway, that little piece. I can pick the inside as well if I want to. I can pick both, it doesn't matter. I can pick both elements, if that makes you feel better. If not, it doesn't matter. I'm just letting you know. The piece you really need to lob off is this little piece. This guy, I just threw it in there for fun. You don't need to pick that inside. You really just need that. This, if you send all the way through, when you hit OK, there's your geometry. There's your object right there. That's the keyway. Exactly where it's supposed to be. And the only reason I know it's exactly where it's supposed to be is because it's dimensioned that way. It is exactly where it's supposed to be. But it took a while to build it. You just can't build it like that. You got to build it. In order to build it from that back point, you need that back point. So you're welcome to review this video later for that, as you want to watch it 10 times to see that. That's okay. The other thing I want to show you, just as a quick thing, is drilling a hole through the side wall of a curved surface. It's a pain in the butt in any software package, so it's always a challenge. How do I do that? There's a few ways to do it. I'm going to show you the tougher of the few ways, meaning that I don't have an interior space where I can just extrude out from the inside. Because I imagine that's how some of you did it. You threw in a plane, for those of you that may have done this already. I think some of you built this already. When you throw in the plane, you can always throw in a plane referencing to another object. See that? And it'll pop on the side of that. Let's say you want it to be parallel, it'll pop to the front of it. Okay. If you did that, that works, but then what happens? Where's the plane? The plane's in the front. Where's the hole? Is the hole in the front? Not. 30 degrees off. You honestly think I'd give you something that was head-on? That's too easy. Nah, not going to do that. So then the challenge is, how do I make something at that angle? The best way, yes, there's more than one method. So I'm going to show you a method, and I'm not going to say it's the best way, I'm just going to say it's a method. The best way ends up being the one that works best for you. Keep that in mind. So each of you approach this a different way. My way, just one way, and I have done this multiple ways in the past. I'm going to go off my top plane, and of all things, I'm going to create some geometry for myself to help me build my shape. So what I drew is a reference line that's vertical. Okay, it's vertical, okay? Change the view so you can see it. Then I'm going to draw another line that's at an angle that I'm going to control with a dimension. In this case, it's going to be set to 30 degrees because that's what they want it set to. Right? That's my way of doing it. One method. Now, you're going to notice that it's at the top. You see that? Now where is this hole really? It's half an inch down. So I might ask myself, would it be better, I'm going to pick the top of this object, and my distance is going to be 0. Would it not be better to create the plane exactly, to create the shape exactly where my plane is? For now, just for illustrative purposes, I'm not going to. I'm not going to do that. Instead, I'm going to leave this plane here, and I have this reference item right there. Okay? What I am going to do is create another plane, and I'm going to use that point and my side wall. See that? I must have picked another spot because it already failed on me. So let me try this one more time. Go back into plane. Okay, side wall. Okay, I need that point because that point's referencing a parameter. It's a reference point. It's not the point. If I pick this, now what do I have? Do you see that? I picked the point, and then I picked that center line. And now what did it do? It gave me a plane perpendicular to this center line in alignment with wherever that point is. That I needed that point and the line to create a plane perpendicular to it. Now when I hit OK, that's what I would be building. And it didn't matter where that line and point reference were. Did you notice that? Should I have put it down here? We can argue that. No, if it was on this plane or on the face, it didn't matter. As my point to you is it didn't matter where it was as long as it was in the correct position. This plane was unnecessary, and this plane is unnecessary. I need neither of them to do this. All I needed was my little sketch right here. Now here's the coolest part about doing this. I can randomly decide to make this some other dimension, 45 degrees, and it literally will clock my plane over to 45. You notice that? Whatever I draw on that plane, it'll just rotate it over. Whatever angle I specified. That's what I like about doing it this way. I have a sketch that's controlling where my plane exists. Get it? That's literally what's happening here. That's what I like about doing this. I can change this to 15 degrees and I'll literally rotate my plane along that tangency, boom, to 15. That's why I like doing it this way. It's not necessary. There's more than one method. It's just, I like the control of being able to rearrange it because 9 times out of 10, at least my background is in custom non-standard products. The customer will change their mind. I don't want to have to rebuild all my planes. Because if I build a scaffolding of planes, it gets a little messy to fix them. Because you end up with a lot of ketchup and mustard. No Chicago hot dogs at all. So that's what I like about this, because I can control, I can drive that plane any way I need to. Then on this plane, I can go ahead, of all things, and go to hole wizard, right on that plane. And go straight to the hole. What size? 3/8? 0.375? 3/8. I won't be through all. That I will tell you. It's up to next that goes to the inside wall. It's not a through hole. Why do we know it's not a through hole? We honestly don't. But it doesn't say through. So we can only assume that it's through one side. Again, something else to note to the customer. Now, position. That's the fun part. Where on earth will I locate this? I'm going to go normal too so I can look at this head on. How do I position this? Well, what do? I dropped it. Make sure you draw in a reference geometry for yourself that you can, you see that vertically clock? I locked it in. And then I'm going to go ahead and just dimension that to the 1/2 inch mark so I drop it correctly. This is all while I'm in the hole wizard, by the way, because that's what you do when you position it. The star is simply the center of the hole. You have control of everything else right up here, like at added dimension, which I did. When you hit OK, there you go. You get a hole drilled through one side at 30 degrees. Now, when the customer comes back and changes their mind and says, no, I want it at 15 degrees, fine. No problem, done. Or you have a product line where you actually have that hole located in 3 different positions. I don't know why. I'm just saying. There you go. Now you can do that. So you can go ahead and do 3 separate product lines off of this same. You can do save as, and just rename it. And the only difference you have in your products is that. Cool? And that's how you drill that hole on the side. The next video I'll show you is how to detail this puppy, because this one requires a little extra finesse on detailing. Any questions before I stop the video and stop this? Cool for now? TMI? Overload? Alright. For now, this will end this video.